All right, so let's get right into video 9. These are all about properties of your definite integrals. And so let's just go through some of them and they'll help us do some shortcuts to use some shortcuts to evaluate integrals. And then we're also going to add something about finding the average function value of a function. So, okay, um, this is the big one. Properties of definite integrals. If I want to find the definite integral, that is defined as the value of b minus a. Now, this one is constant, so you're going to see this come up because this is a specific rectangle. So we'll see that happen. But basically, if you've got a graph that's just a y value, so let's say it's up here at y equals 5. If you want to know the area, then if you think about that, that's just going to be whatever the width of b to a is. So b minus a times your height, which in this case would have been 5. Okay. For the next one, this is the big one, if you're doing the integral of a to b of a constant, you can bring the constant out front and you can do the same thing for the function. If it's from a to a, which doesn't really go anywhere, then that area is 0. If c ends up being bigger than d, so like if you have a bigger number on the bottom of your function, for example, you can switch it. You could switch them and it becomes a negative. It's kind of like you're thinking of it as subtraction, but you're taking the subtraction out. So this become negative from 3 to 4, which is much easier for you to visualize. So I suggest doing that. This one just says if you have addition or subtraction, you can separate this. And this one says if you want to go from A to B, but A to B is perhaps made up of an interval along the way, like from C, you can add this with that and you'd get the total area, which I think should make sense. So there's also, so this is another one of our theorems. So our theorem says if your function is greater than 0 for the whole interval, then your area should be positive, which makes sense, I think. This one says if your function f is always bigger than g, then when you find the area for f, it's always going to be bigger than the area for the g function. Again, I think both of those probably make sense to you logically if you think about it. This is the new piece, this idea of an average value of a function. So if f is a continuous function on a to b, then the average value is this. Well, let's think about why. This value right here is your total value. So you're just going to take that total value and divide by how big this interval is. So literally, you're just splitting it up into how long it is. That's it. So that's how you're finding the average value. Average should make sense. Okay. So let's take a look at some examples. We're actually just going to do these 4, and then you're ready to start your problem set. So here's what I know. I know my function f is continuous. I know that from 0 to 4, the integral of my function is 5, or the area is 5. And from 4 to 2, which notice that 4 is bigger, it's -1. So if it were me, the first thing I would do if this is flip-flopped is to change it back. But then that would be the negative version, so that would actually end up coming out to a +1, and I would write that down. Okay, so then what is 0 to 2? Well, if you take a look at what you're given 0 to 4, you know 2 to 4 is 1, so you can think of this as, well, this would be 0 to 4 minus the part I don't want, which is from 2 to 4. So I end up with 5 minus, now careful, 2 to 4, we switched back to a +1, so the area from 0 to 2 should just be 4. Okay, for this guy here, I would absolutely bring out the 3. So I have 3 from 0 to 4, f of x dx. Anything that doesn't actually have a width, like this is 2 to 2, we know that's going to be 0. And then last but not least, I've got 2 to 4. 2 to 4, I already flipped, so I know instead of being a 1, or excuse me, instead of being a -1, it's a 1. So that part's 1, and I still have to figure this out. Well, this we already know from up here, so we really have 3 times 5 minus 0 plus 1, so we have 16. Okay, down here we have the integral from 2 to 4 of f of x minus 1. Now you should know from your rules that I can split this up into 2 to 4 of f of x minus 2 to 4 of dx, excuse me, minus 1 dx. Okay, so now we're going to have to deal with these separately. Now you already know 2 to 4 is, again, remember we flipped this, +1 minus, now this, remember guys, this is just a constant. This is 1. That means this is like having a graph that's at 1 the whole time, and I'm going from 2 to 4. So this is a rectangle with a height of 1 and a width of 2. So this total area ends up just being 2. So we're going to subtract 2, so we get an area of -1. Okay. And then the last one asks us to find the average value of f on this interval. So the average value, remember, should be 1 over the difference of your interval, so 4 minus 0, of your integral from 0 to 4 between those two values of f of x dx. So let's put in what we know. That would be 1/4 of, we know the integral from 0 to 4 of our function is 5, so that's just 5/4 is my average value along the way. All right, that's it. I told you it was a short one. Good luck with the problem sets. I'll see you.